Have you ever pondered how a single radio device can cater to countless communication needs? Or envisioned morphing a standard computer into a comprehensive radio communication device? Welcome to the world of software-defined radio, a revolutionary technology that's redefining our approach to communication. Instead of relying on traditional hardware components, software-defined radio, or SDR, uses software to determine its radio capabilities. This allows it to handle a wide spectrum of radio signals across various frequencies. Imagine possessing a single device that can effortlessly switch between cell phone signals, satellite communication, and even amateur radio frequencies. All of this achieved not by changing physical components, but simply by tweaking the software. And this, my friends, is the magic of software-defined radio, the game changer in the world of communication. In the past, traditional radio hardware came with set functionalities. Each device was designed for a specific purpose, and switching between different communication protocols or frequencies required multiple devices. This rigidity in hardware was both inefficient and costly. As the world of technology ushered in the era of digital transformation, the need for a more flexible solution became evident. Enter software-defined radio, or SDR. SDR revolutionized radio technology by shifting the determination of radio capabilities from hardware to software. This pivotal shift meant that a single radio device could now handle a multitude of communication needs simply by changing the software. It was like having a universal remote for all radio communication. The emergence of SDR marked a departure from fixed, purpose-specific devices to a more flexible and adaptable system. Thus, the shift to SDR marked a major leap in radio technology, opening new avenues in communication. Now, you may wonder, how does SDR work? Well, the magic of software-defined radio begins with its basic architecture. This architecture is a beautiful harmony of various components, each playing a critical role in the process of radio communication. Picture the scene. The radio frequency, or RF front end, is the first to take center stage. It's like the conductor of an orchestra, capturing radio signals from the air. These signals are then passed on to the analog to digital converter, commonly known as the ADC. The ADC is like the musicians in our orchestra, converting these analog signals into digital form, a language that the computer can understand. Now, the software, the true maestro of this ensemble, takes over. It's in the driver's seat, controlling the demodulation, decoding, and handling of the signal. It's like a virtuoso pianist adeptly manipulating the keys to produce a symphony of communication protocols and frequencies. But what makes this process even more mesmerizing is the software's ability to adapt. It can switch between different frequencies and protocols with a simple software update. This is akin to our pianist effortlessly transitioning between classical, jazz, and rock, all while keeping the rhythm of the music flowing smoothly. The beauty of SDR lies in this intricate process. It transforms a standard computer into a universal radio communication device capable of speaking many languages. It's like having a multilingual maestro conducting an orchestra of diverse instruments, producing a symphony of communication that adapts and evolves with the times. And there you have it. This intricate process underlines the flexibility of SDR, enabling seamless switching between communication protocols and frequencies. It's a fascinating world where software, not hardware, defines the rhythm of radio communication. So, where do we see SDR in action, you might ask? Well, its applications are as diverse as they are transformative. Let's dive in and explore some of them. Software-defined radio is a game changer in the world of communication. It's like a chameleon, seamlessly adapting to various communication forms. Take cell phones, for instance. Your phone needs to handle an array of signals, from voice calls and text messages to data transmission. That's SDR working behind the scenes, enabling your device to switch between these tasks smoothly. But that's not all. SDR is also making waves in space. Yes, you heard that right. It's a vital cog in satellite communications. Satellites have to deal with a myriad of communication protocols and frequencies. SDR offers the flexibility they need, allowing them to adapt and communicate effectively. Moving from the outer space to the labs, SDR plays a pivotal role in research and development. Researchers can experiment with new radio frequencies, communication protocols, and even test cutting-edge technologies. SDR is like a playground for them, offering a sandbox to innovate and explore. Now, let's switch gears and look at a more serious application: military and emergency services. In these fields, communication can make the difference between life and death. SDR's ability to switch rapidly between communication systems is a lifesaver, literally. It allows for effective coordination, ensuring that help arrives when and where it's needed. Indeed, SDR's versatility makes it a robust tool in diverse fields, revolutionizing communication as we know it. From your pocket to the cosmos, from labs to the battlegrounds, SDR is there, silently redefining how we communicate. And this, my friends, is just the beginning. The future holds even more exciting possibilities for SDR, but that's a story for another time. With such extensive applications, the benefits of SDR are manifold. The flexibility of SDR is a standout advantage, as its software-centric nature allows for easy upgrades and changes to meet evolving communication needs. This adaptability also extends to cost efficiency. By replacing multiple hardware-based devices with a single software-defined one, SDR significantly reduces costs. Moreover, the rise of open-source SDR projects has fostered a vibrant community of innovators, offering a platform for individuals and small organizations to experiment and push the boundaries of radio communication. Moving into the future, SDR is set to play a pivotal role in emerging technologies. It's being integrated with fifth-generation networks, enhancing data processing and connectivity. SDR's adaptability also makes it a key player in the Internet of Things, where devices need to communicate seamlessly across various protocols and frequencies. In essence, SDR exemplifies the convergence of technology and innovation, heralding a new era in the world of communication.